friction. So friction is caused by the adhesion of one surface to the other and by the interlocking of irregularities in the rubbing surfaces. So friction, it exists when two rubbing surfaces interact. Two surfaces interact with each other. So we have formulas. We have two kinds of friction, which they are static friction and kinetic friction. Static friction, it exists between two surfaces when motion is impending. It is defined by the formula: the static frictional force is less than or equal to the coefficient of static friction times the normal force. So it exists between two surfaces when motion is impending. What do we mean by impending? That is the motion, or what that is the motion wherein I mean the that is the friction wherein the object that is I mean the two surfaces are still not the object that is in contact on the surface is still not moving. So, pag na-reach na or nag-exceed na si frictional force, pag nag-exceed na yung na siya sa static friction, that means magkakaroon na siya ng motion. So, when the static friction is less, so when the value of this one is less than or equal the static friction, which is the maximum amount of friction until for impending motion, that means that the object in contact to the surface will still not move. So, sa kinetic friction naman, it exists when two surfaces are in relative motion. So, pag nagkaroon na ng motion yung object na nasa surface or na nag-slide na siya, that is, doon na yung mag-exist yung kinetic friction. So, that is in the formula of kinetic friction equals to the coefficient of kinetic friction equals the normal force. So, these are the problem-solving strategy. Number 1, friction forces are parallel to the surfaces and directly oppose the motion or impending motion. Number 2, the maximum force of static friction is usually larger than the force of kinetic friction for the same materials. Number 3, in drawing free body diagrams, it is usually better to choose x-axis along the direction of motion and the y-axis normal to the direction of motion or impending motion. Number 4, the first condition of equilibrium can be applied to set up two equations representing forces along and perpendicular to the plane of motion. And also the relations of the static friction, which is less than or equal to the coefficient of static friction times the normal force, and the kinetic friction equal to the coefficient of kinetic friction times the normal force, can be applied to solve for the desired quantity. Number 6, normal force should never be assumed to be equal to the weight. So, yan. Because when it is determine its magnitude by summing forces along the normal axis. So, problem number 5. Consider masses M1 is equal to 20 kg and M2 equals to 18 kg in the system represented by the figure. Assume that the coefficient of kinetic friction is 0.1 and the inclination angle theta is 30 degrees. So find the acceleration of the system and B, what is the tension in the cord. So first thing we have to do is to analyze the figure. We are given here the mass of two blocks which are 20 kilograms and 18 kilograms. We also have the coefficient of kinetic friction, and since the acceleration is directed to the right, therefore the direction of the friction must oppose the motion, therefore it is to the left. Next is the tension that exists here in the cord, which is which is equal to the weight of the block 2. So this is tension 2. Tension, which is equal to M2G. So now we already have these things, and of course, let's not forget the normal force. So that is the normal force. Let's call it N. So we can now get the free body diagram. So we have a 30 degrees here. So since this is 30 degrees, technically this is 60 degrees. So let's use this axis na lang para mas mabilis natin ma-determine yung mga angles. So this is the x-axis. And we have here the y-axis. Alisin ko. Palitan ko ng. So this is the x and y plane. This is x and y plane, and let's plot the forces. We have here the normal force. This is the object, which has a value of 20 kilogram times 9.8. Then we also have a degree of 60 degrees here. Then we also have the tension, which we can call M2G. Then we also have the friction, kinetic friction here, which is the coefficient of friction times the normal force. So that would be our diagram. So in our next slide, we will solve letter A. So for letter A, we will find the acceleration of the system. So our first step is to create the equation. So ulitin lang natin dito. This is M2G, M1G. Then we have here the normal force. We have here the friction. And we have here the tension, which is equal to M2G. So constructing the equation, we know that from here we can use the summation. Di ba normally we ginagamit yung f of x equal to 0 and f of y is equal to 0. But then, this system is in motion. Therefore, the conditions for equilibrium is not satisfied. Therefore, we can use these conditions. So we are going to use the summation f is equal to ma. So for the summation of f of x, that is equal to for all x-axis here, for all the components with x-axis here, that is m1g, m2g, m2g pala, m2g minus yung coefficient of friction natin times yung ating normal force yung sine 60. So that is M1G sine 60 degrees. This is 60 degrees kanina. Then, we also have minus M1G. So this is your normal force. Then yung sunod, minus M1G cosine 60 degrees. Then that is equal to yung sa mass times acceleration, that is M1 plus M2 times yung acceleration. So for letter A, we are finding the acceleration of the system. So we can manipulate this formula na lang. So that would be A be equal to dividing both sides by M1 plus M2. That would be M2 minus G minus the coefficient of friction times M1G sine 60 minus M1G cosine 60 all over M1 plus M2. Then, we now substitute the values that we have. So, our M2 is, this is M2G. We don't have minus there. That will be M2G. It is 18 kilograms times 9.8 minus yung yung ating coefficient of kinetic friction, that is equal to 0.1 times yung M1, which is 20 kilograms, times the acceleration due to gravity, that is 9.8 times sine 60 minus yung M1, which is again 20 kilograms times 9.8 then cosine 60 all over 20 plus 18. So, compute natin sa calculator. That is 18 times 9.8 minus 0.1 times 20 times 9.8 times sin 60 minus 20 times 9.8 cosine 60 all over 20 plus 18. So, our answer would be 161.616. So that is approximately 1.62 meter per second square. So that is the acceleration of the system. So itong acceleration na nag-exist sa when the mass is 20 kilograms on the first block and 18 kilograms on the second block, and there exists a coefficient of friction which is 0.1, and it is inclined, and this whole system is inclined in a plane that which is 30 degrees. So the acceleration would be 1.62 meter per second square. Our next question is, what is the tension in the cord? So we are looking for the tension, which is ito. So to solve for that, that is yung acceleration na nag-exist dito, which is M2G, M2A minus, yung mass, which is M2G minus the M2J, which is equal to the tension. Since ito, ito yung ating mass or weight mismo yung weight nung block. Then also the acceleration that is applied by the pulley. So solve for the tension, that is M2G minus M2A. Substitute the value. Your M2 is 18 times the gravity 9.8 minus yung M2. Yung M2 natin ulit ay 18 times yung acceleration na 2 meters per second. So your answer would be, yung acceleration pala ay 1.62. Sorry. That is 1.62. Ulit barahin ko. So that is 1.62. Yan. So the answer for the tension would be 147 Newton. That is for this problem. Problem number 6. A loaded penguin sled weighing 80 Newton rests on a plane inclined at angle theta is equal to 20 degrees to the horizontal. So between the sled and the plane, the coefficient of static friction is 0.25 and the coefficient of kinetic friction is 0.15. A. What is the least magnitude of the force parallel to the plane that will prevent the sled from slipping down the plane? And letter B. What is the minimum magnitude F that will start the sled moving up the plane? Letter C. What value of F is required to move the sled up the plane at constant velocity? So if we will try to illustrate the problem, it goes like this. Nung sabi, meron tayong inclined plane which is provided as 20 degrees inclined. Then, meron daw na sled. So, let's call it, kung kumari ganito yung itsura ng sled. So, ganyan. And that is 18 Newton. And this sled is 18 Newton. And between the sled and the plane, meron tayong coefficient of static friction na 0.25 and the kinetic friction which is 0.15. So if we are to solve for letter A, gawa tayo ng, so ang letter A natin list magnitude of force parallel to the plane that will prevent the sled from slipping down the plane. So if we will illustrate the free body diagram for letter A, ang sabi, force parallel, may ga-apply ka ng force parallel to the plane and yung ating sled ay mape-prevent from slipping down the plane. Dapat iba yung kulay. Yan, dito. So, meron tayo dito, from the figure, meron tayong nag-exist na normal force. Tapos sabi ay meron tayong i-apply na force parallel to the plane. So, ito yung ating plane, itong anong to. So, that is parallel, so that would be F. We call it F. Then, ang sabi, it will prevent the sled from slipping down the plane. Therefore, our static friction is also at this direction. So, this is our F, small f. Then, also, we have the weight of the sled, which is 18 Newton. And it goes downward. So, kung igagawa natin siya, kung i-isolate natin yung free body diagram niya, that would be like this. Ito na yung ating magiging x direction. Then, ito na yung ating y direction. So, meron tayong normal force dito. Meron din tayong friction. And meron tayong applied force. Then, meron tayong weight. And then, we call this part the vertical vertical component of y of the weight, then this part would be the horizontal component of W. So if we will try to solve for the normal force, that is technically equal to, that must be equal to the vertical component of the weight, since dapat walang motion sa hindi tayo magkakaroon ng vertical motion, since ang ating motion ng sled ay is either pataas or pababa lamang ng plane. So therefore n is equal to wy. So now let's proceed to the next, proceed tayo sa next slide para makuha na, para ano. So, dito, given yung ating, now let's proceed. Sorry. So, we are given with the normal, di ba yung ating, ano kayo na ganito? Yung ating, ito yung ating letter A. So, meron tayong free body diagram na ganito. Ito yung ating XY direction. Ito yung ating X direction. So, if we will put again those forces, ito yung ating N. Ito yung ating friction, then meron tayong applied force na F. Then, meron din tayong, then, sabi kanina, meron tayong, now let's proceed to the, ba yan? Meron tayong, X component ni weight. Meron din tayong Y component, W. And then yung ating mismong weight. So if we will compute for the force, for the applied force, in order to, that will prevent the sled from slipping down. So ang ating mangyayari is, we will be using the summation of f of x here, which is equal to 0. So that would be the friction plus yung ating applied force, since lahat yun ay x component, then minus yung wx, and then equal to 0. So kung i-expand natin yung formula na yan, yung equation na to, that would be your f would be, di ba ang ating friction force ay is equal to the coefficient times the normal force. So for this part, our coefficient would be static for static friction, since ang ating goal ay wag mo nang gagalaw si sled. So that would be coefficient of static friction times yung normal force, which is equivalent to Wy, plus yung F natin, nahahanapin natin, then minus Wx equal to 0. Then expand pa natin ulit. So that would be yung ating coefficient ay 0.25 times yung Wy, which is equal to W sin theta. Mapala, di ba kanina we are given with 20 degrees here? So sabi 20 degrees siya naka-inclined. So therefore, if you will solve for the angle here that with respect to the x-axis, that must be 70. Since ito ay isang right triangle, so kung magkaganyan ka, right triangle, that is 20 degrees. So this part will be 70, so this part will be 90. Diba? So that is the angle. So for this part, that is plus F. So Wy would be 80. Then sin 70. plus F minus yung WX natin, which is 80 cosine 70 equals 0. So, if you are to solve for the force, then i-transpose nyo tong mga to sa kanan. So, that would be F is equal to 80 cosine 70 minus 0.25 times 80 times 80 times sine 70 is equal to, yan, wala na. Then, solve for F. F would be equal to 8.57 Newton. So, that would be the force required to prevent the sled from slipping down the plane. So, that is for letter A. So, for letter B naman, ang tanong is, now let's proceed to the... So, ang tanong sa letter B is, yung force naman, or yung minimum force na kailangan para hindi, ang sunod naman sa letter B is yung required force para minimum magnitude that will start the sled moving up the plane. So, if we will draw the FBD of that would be like this. So, ito yung ating ulit y direction. Ito yung ating x direction. So, that would be the normal force. Here's the normal force. Then, meron tayong force here. And now, ang ating friction is downward na. Then, meron tayong weight dito. Then, nandito pa rin yung ating WX. And then, meron pa rin tayong WY. This is W. So, ngayon, ang ating gagawin is using the summation of fx is equal to 0. So, we will use this to solve for the f. So, that would be f minus yung wx, that is weight cosine theta, minus yung friction. And that is equal to 0. Then, equate to 0. Then, solve for f. Ang ating equation would be f is equal to w cosine theta. And then, yung ating friction, that is the same as the coefficient of static friction times the normal force, which is wherein the normal force is equal to w sine theta. Therefore, that would be plus coefficient of static friction times yung normal force natin na w sine theta. So, substitute the values. F is equal to 80 cosine 70 plus 0.25. Yung W natin ay 80 times yung sine theta, which is sine 70. So, alam niyo naman kung bakit sa nagaling yung 70, diba? Dito yan. So, calculate mo yung value ni F. That would be 46.2 Newton. So, that would be the minimum magnitude para mag-move up yung sled. Since nag-move up nga yung sled, therefore, yung ating friction dapat ay opposite doon. So, kaya naging papunta dito yung ating friction. Diba kaya napapagantan siya? Pataas siya. Kasi, prevent from moving the sled. So, that is That means, hindi siya gagalaw dapat si sled normally nung ano. So, sa letter B naman, sabi, pababa na mag-i-slide na daw si sled. So, mag-move up para siya pataas. So, dapat yung ating friction ay pababa. So, sunod naman is yung letter C. Yung letter C natin is, ang tanong ay, yung force na required so that magkakaroon siya ng constant velocity moving upwards. So, kung moving upwards, we have the same we will be having the same FBD. So, hindi ko na siya i-draw ulit. Ganito lang ulit yung FBD niya. Since pataas yung movement nung sled, so, bababa dapat si friction. Then, meron tayong parallel applied force na F. Then, normal force. Then, the weight. And then, the x component of the weight, then the y component. So, yan yung mag-exist na forces sa ating FBD. So, to compute, so same pa rin, summation of fx is equal to 0, and our, would be f minus w cosine theta minus f equals 0. At this point, since magkakaroon na siya ng motion, ang gagamitin na natin na coefficient of friction ay coefficient of kinetic friction na. That would be F is equal to W cosine theta plus yung coefficient of kinetic friction times W sine theta. Substitute mo yung values, that would be F is equal to 80 cosine 70 plus 0.15 times 80 sine 70. So, solve for F, that would be F is equal to 38.6. And that would be for letter C. So, that is all for this problem. So, for the references, these are the references. And thank you for listening. See you in the next lesson. Bye-bye.